Now the next example is trace y square is equal to x cube into 4 minus x. For tracing this curve, again we need to verify all the points. The first point is symmetry. So in symmetry, as given equation of curve contains even and only one power of y, and therefore it is symmetric about x-axis. So curve is symmetric about x-axis. Now the second point to trace the curve, it is origin. Here we check whether curve passes through origin or not. So how to assess? Put x is equal to 0, y is equal to 0 in the given equation, and when I substitute x0 and y0, LHS is 0, RHS is 0, therefore equation gets satisfied, and therefore curve passes through origin. Now once curve passes through origin, the next work is to calculate equation of tangent at origin. How we calculate equation of tangent at origin? Equate the lowest degree term from the equation to 0. So for that, consider y square is equal to 4x cube minus x raised to 4. Now in this equation, degrees 2, degrees 3, degrees 4. So here lowest degree term is y square, and when I equate this lowest degree term to 0, we will get y square is equal to 0, and this implies y equal to 0 and y equal to 0. So there are two tangents. These two tangents are real and same, and therefore origin is a cusp. So origin is a cusp. Okay. Now the next point is points other than origin. In this, what we do to get point of intersection on x-axis, put y is equal to 0. To get point on y-axis, put x is equal to 0. So put y equal to 0 to get point on x-axis. We get x cube into 4 minus x is equal to 0. This implies x cube is equal to 0. This implies x cube is equal to 0 and 4 minus x is equal to 0. So this will give us x is equal to 0 and x is equal to 4. So by putting y0, we got two values of x. That is x is 0 and x is 4. So 0, 0, 0, 0 and 4, 0 are the points with x-axis. 0, 0 and 4, 0 are the points with x-axis. Now to get point on y-axis, what we do? Put x is equal to 0, and when x is 0, this is 0. So right hand side is 0, and therefore y square 0 implies y is equal to 0. Thus origin is the only point with y-axis. Origin is the only point with y-axis. So overall, there is only one point which is apart from origin. That point is 4, 0. So if there is a point other than origin, the next work is to calculate equation of tangent at this point, 4, 0. And to get the tangent at this point, we use shift of origin. So which transformations we are going to use? So I will write to get tangent, replace x by x plus 4 and y by y plus 0, because here we are going to shift the origin to the point 4 comma 0, and therefore I will use the transformation as x is x plus 4 and y is y plus 0. And when I replace these values in the given equation, what we will get? Capital Y square is equal to, here x plus 4 bracket cube and in bracket 4 minus x, so it will be x plus 4 and then bracket complete, and this is nothing but y square is equal to x cube plus 3a square b, so it is 12x square plus 3ab square. So b square is 16, 16 into 3, it is 48, so 48x plus b cube, it is 64, bracket complete, and here 4 will get cancelled, the remaining minus x. Now after shifting of origin, to get the tangent, what we do? We equate the lowest degree term from this equation to 0. So which is the lowest degree term? Here degree is 2. When I multiply this x cube with this x, degree is 4. X square with x, degree is 3. X with x, degree is 2. But this constant into x, degree is 1. So lowest degree term is minus 64 into x is equal to 0. And this implies x is equal to 0. And what is this capital X? It is x minus 4. So x minus 4 is equal to 0 implies x is equal to 4. Thus, at the point 4 comma 0, the tangent is x is equal to 4. Okay? Now to get asymptote parallel to x-axis, what is the procedure? Equate the coefficient of highest power of x to 0. Similarly, to get asymptote parallel to y-axis, equate the coefficient of highest power of y to 0. So in this equation, if I consider the equation is y square is equal to 4x cube minus x raised to 4. So here highest power of x is x raised to 4, but its coefficient is minus 1 and that is constant. As coefficient of highest power of x is constant, therefore asymptote parallel to x-axis is absent. Similarly, highest power of y is y square, again its coefficient is constant and therefore asymptote parallel to y-axis is also absent. So for the given curve, asymptote parallel to both the axes are absent. So here I will write asymptotes are absent. Asymptotes are absent. Now the next point to trace the curve is region of absence. Region of absence. Okay. Now in region of absence, what we do? We will draw x-axis and y-axis. What are the steps involved in region of absence? Step number 1, plot the points of intersections. Step number 2, if asymptote is present, then asymptote itself is one of the partition. Step 3, draw the partitions. Step 4, define the partitions. And step 5, check in each partition whether curve is present or not. So here, first we will plot the points of intersection, and the points of intersections are only origin and 4 comma 0. So I will plot origin as this dot, and suppose the point 4 comma 0 is here. So this is 4 comma 0. Now if asymptote is present, then asymptote itself is one of the partition. But here asymptotes are absent. So there is no necessity to draw the asymptote. And as points are on x-axis, we will draw the partitions parallel to y-axis. So already this is y-axis, and I will draw one more line which is parallel to y-axis and passing through the point 4 comma 0. So total there are three partitions, 1, 2 and 3. Now we will define each partition. How we define this first partition? This first partition is x less than 0 because on left side of y-axis always x is negative. This middle partition we can define it as 0, less than x, less than 4, and the last partition it is x greater than 4. Now after defining each partition, choose the value of x from each partition. So here for x less than 0, I will choose x is equal to -1. Friends, I have not chosen the value of x as a -a because our points are 0, 0, 4, 0. In last example, what was the situation? The points were 0, 0 to a 0. So points were in the form of a, but here points are in the form of number. So where x is -1, what is the value of y square? So y square is equal to, here equation is x cube into 4 minus x. Where x is -1, this is negative, and 4 minus of -1, this is positive. So positive into negative, it is negative. So y square less than 0, and if y square is negative, so in this partition curve is absent. Similarly, choose value of x as 2 for this partition because 2 lies in between 0 and 4. When value of x is 2, what is y square? This is 8, it is positive, and 4 minus 2, this is also positive. So y square is positive in this partition, and therefore curve is present in this fourth partition. Now in third partition, choose value of x is 5 because the third partition is x greater than 4. So choose value of x is 5. When x is 5, this is positive, but here it is negative. So y square is negative, and therefore curve is absent in third partition. Okay. So now we will proceed to the last point, that is shape of the curve. Shape of the curve. Now when tracing the curve, first we will draw x-axis and y-axis. Okay. Now symmetry we will see at the last. Second point, origin. Yes, origin is present. So I will plot it as dot. At origin, what is the tangent? At origin, the tangent is y is equal to 0. So this line is tangent. Okay. If this line is tangent, at origin, the curve will have shape either on this side or it will be on this side. Isn't it? Now, if curve have shape on both sides, but before origin, if you see, before origin, in this partition, curve is absent. So, here curve is absent, and therefore, I will erase this part of the curve. Okay? And such part of the curve at origin, it is called cusp. Now the next point is points other than origin. Yes, there is one point other than origin, and that is 4, 0. Suppose I will represent that point as 4, 0. At this point, what is the tangent? The tangent at 4, 0, it is x is equal to 4. Just now we have calculated. So x is equal to 4, it means this is the line passes through the point 4, 0. If this line is tangent at 4, 0, the probable curves are either it is on this side or it is on this side. But in region of absence, already we have checked, after 4 the curve is absent. So after 4 we will have to erase this part of the curve. Okay. And if two curves lies in same partition, so join these two curves. And when I join these two curves, I will get this shape like this. And as this curve is symmetric about x-axis, so the remaining part it will be like this. So this point is origin. So this is the shape of the curve. Okay, is it understood?